Are you ready for some science? Are you?
It has begun!
Alright, let me start out by saying this. What I'm going to describe to you comes from simply my own logical deduction using basic science and physics I learned in like 5th grade. Okay? And those three aspects are: 1, the atomic particle has a neutron with no charge, a proton with positive charge, electron with negative charge. Okay, they described the atomic nucleus in like 5th grade. 2, we played with magnets, learning that like charges repel, opposite charges attract. And of course you have the reality of, in outer space, where if a satellite is too dense, has too much mass, it'll slam into the planet. It will not sustain orbit. So going off that, the subatomic particles, magnetism, and density, mass, we're going to break down the mathematical relationship of subatomic particles. Again, I reiterate, I have not studied any of this, I have not researched it, I have not acquired the technology to vet this out. This is simply logical deduction. So, okay, the subatomic particle has the proton, neutron, and electron. Proton has a positive charge. The electron has a negative charge. Neutron has no charge. Or does it? Consider this. Going back to the idea that opposite charges attract, what keeps the electron from slamming into the proton? There must be a counterbalance charge there. Is it possible? Maybe. But then again, right? On that same point of opposite charges attract, what is causing the proton to link up with the neutron? I hereby hypothesize that the neutron has a negative charge, though quite negligible. It would have to have some kind of negative charge to attract the proton, but also be a counterbalance to keep the electron from slamming into the proton. Right, yes, okay. Now each one of those subatomic particles can be defined by two mathematical factors. One being spin. Spin gives it its charge. To get a negative charge, you spin one way. To get a positive charge, you spin the other way on the axis. What's the other mathematical factor? Density or vibration. That the slower a particle vibrates, the more density it has. So if you have those two mathematical factors deciding the relationships of these particles, let's work that out. Okay? That would mean that density times spin equals the power of the charge. Okay, so we're going to argue that based on that, right? Think about it mathematically. If you have a 3 density and a 2 charge, a 3 density and a 2 spin, you have a 6 charge. If you have a 6 density and a 1 spin, you have a 6 charge. So I'm here to argue that the neutron looks like it has no charge because it has an extremely slow spin and an extremely high density. giving it a much stronger negative charge. Now, giving it a strong enough negative charge to keep the electron at bay, but attract the proton. Which means the proton, if say the neutron has a 6 negative charge, we'll go with that number. The proton has, could you argue, a 6 positive charge, so that they attract each other, but they balance out the orbit of the electron. Yeah, you could argue that. Again, this is all just logical deduction from basic science I learned many years ago.
Is it over?